Jingle bells in the dead of night. Oh, what fear it is to hide from the things that start with might. Jingle bells in the haunted night. Oh, what dread it is to roam through the darkness filled with fright.
Deep in the night, everything seems still as the snow slowly falls on the town of Wareville. But behind it all, there's a plan that could kill. There will be no sock miss if the mayor has his will. With malicious software, but there's a flicker from the hill. They call it Mount Hackett, the home of the glitch. The wares can't stand it, now they treat him like a witch. Just another evil hacker out to gobble up the kids. But behind all the trash and the monitor cliffs, there's a deep cave covered with a floppy disk. Inside of the cave, there's a single gaming chair. It's the throne of the glitch as he hides in his lair. He's misunderstood, but he says he doesn't care. Say he's actually good and he targets malware. He's misunderstood, but he says he doesn't care. Say he's actually good, yeah, let's target malware.
Jingle bells in the dead of night. Oh, what fear it is to hide from the things that start with might. Jingle bells in the haunted night. Oh, what dread it is to roam through the darkness filled with fright.
Back in the town, preparations begin. Marty May Ware climbs the stage once again. She's the one in charge of the celebration. As she begins to talk, everything just ends. The power turns off and she's looking at her friends. But back in the sock, the alerts start to sound. Mount Hackett's IP has been identified and found. It must be the glitch trying to hit back at the town. McSkitty leaves quick and heads straight for the cave, ready to inflict pain. But Glitch is at the door. He's ready for this moment to tell her he's in a war with the mayor of the town, who is evil to the core. He explains a little more, how his keyboard is a sword, and to even up the score, he really needs our help. Get your black hoodie on and the VM you've been dealt. Together we are strong, saving sockness from the melts.
Jingle bells in the dead of night. Oh, what fear it is to hide from the things that start with might. Jingle bells in the haunted night. Oh, what dread it is to roam through the darkness filled with fright.
Welcome to day number 17 of TryHackMe's Advent of Cyber. My name is Tyler Ramsbey, and I get to be the one to guide you to today's task. Now, today we're going to get hands-on with some log analysis, threat hunting, Splunk, SIMs, all of that fun stuff. But before we do that, let's begin with the story and figure out where we are at in our story of saving Sockmas. So here we are, let's begin. An attack now, it seems, on the town's CCTV. There's a problem with the logs, but what could it be? An idea put forward of a log format switch, not as expected, the idea of the glitch. So here's the background story. Marty May Ware is going crazy. Someone has disconnected the main server from the Wareville network and nobody knows who it is. As soon as she realizes it, she contacted Wareville's top physical security company, WareSec and Aware, to let her view the data center CCTV streams. They forbade it entirely for privacy reasons. Only the camera owner can view the recordings. Not even the WareSec and Aware employees themselves are allowed to do so. Still, they said there was no recording of anybody entering the data center yesterday. How could that be? Wondered Marty May, desperate for answers. Their first supposition was that the owner of the cameras must have deleted the recordings from their managing web app. But the data center's camera owner surely can't be the perpetrator. It is no other than Byte, Glitch's dog. Glitch insisted with Marta to leave the ownership of the cameras to Byte precisely to avoid these kinds of happenings. Byte, the ultimate good boy, combines loyalty and sharp instincts to keep any place safe. Marty May calls Glitch and McSkitty right away, explaining the situation in between the sobs. Glitch's eyes darken. Someone is trying to frame Byte, and he will not let anybody vex his beautiful dog. McSkitty is perplexed. Why are the people at WareSec and Aware supposing that Byte had deleted the recordings? Shouldn't they have some logs to prove such an accusation? Marty May has the answer. They do have some log files that they back up every 6 hours, give or take, but they can't search through it, or rather, they tried. But when they go and search for some keyword like the data center camera's ID or the action delete, this is what they get. And when we look at this, we can see this is definitely not helpful, right? They're trying to cat this out. So that means I want to read this file and then grep. That's how you search for stuff in a Linux file. 11, well, it's not super helpful. Same here with the delete. It's not super helpful. It's unreadable. McSkitty shakes her head. They must immediately send the log file to the SOC team. Armed with the SIM, no log is unsearchable. And hey, if you're new to TryHackMe, new to some of these words, the cool thing about TryHackMe is there's a dictionary built in. So, for example, if we didn't know what a SIM is, we can click this, and it says this: Security Information and Event Management System that is used to aggregate security information in the form of logs, alerts, artifacts, and events into a centralized platform that would allow security analysts to perform near real-time analysis during security monitoring. So what are our learning objectives for today's task? Well, number 1, we're going to learn how to extract custom fields in Splunk. Number 2, we're going to learn how to create a parser for the custom logs. Number 3, we're going to filter and narrow down the search results using search processing language. And number 4, we're going to learn how to investigate in Splunk. Now, we do need to click Start Machine. I've already done that to speed up the process, but you do need to click that, and it does take about 3 minutes for it to go through. If at first you get a gateway error by trying to access the URL, you just need to give it a few more minutes. So make sure right now you click Start Machine and then pause my video and unpause it after your machine has started. Additionally, if we look at our connection details, you do not need the attack box and you do not need to be on a VPN. All you need to do is start the virtual machine here, and it will give you a direct link that's available that you can access just directly from your computer. No VPN, no VM required. So go ahead and do that, and then I'll meet you back here once your machine is ready to go. All right, once your machine is up and running, you will see a URL right here. Once again, you don't need to be on the VPN or the attack box. You can just click that and it'll open up the Splunk instance in another tab in your web browser. Once you open it up, you're going to be greeted by this screen here on Splunk Enterprise. What we need to do first is click Search and Reporting. Now, once we click Search and Reporting, there's a few things we want to do. The first is we just want to see all the data that's been ingested into Splunk. We can do that by doing index equals and then our wildcard, or asterisk, and we want to change this from 24 hours to all time. And then we'll click search. Once we do this, you can see we have a bunch of different data right here, but what's going to be most helpful for us is figure out what source types are here. So we know that this is ingesting 2 different sources into Splunk. And the way we know that is on the left side where we have these different fields. If you click source type over here, we have 2 values: web log and CCTV logs. Well, we're going to begin with the CCTV logs. Remember, we are investigating how footage was possibly deleted, how the server was unplugged, what exactly is going on, how can we parse these logs? So once again, click source type over here and then click CCTV logs. And you can see that now we have our index and our source type of CCTV logs, and we have a little more information here, but it's not exactly helpful. Our fields aren't super helpful over here. We have some host, recording ID, source, things like that. We have our interesting fields. We have one more field here, but not super helpful for us because, well, it's not parsing it properly. So for example, if we go to any one of these fields, so we'll just go here, you can see the information is pulling down. We show our source. Here's what it looks like, our source information. We have what appears to be a timestamp here, an event here, some number, maybe a user ID, username, and a session ID. Now, if we back out of this real quick, so if you just hit the back arrow, I'm back out of here real quick and hit back. Actually, just open it in a new tab. So there we go there. You can see it's not exactly copying all this because here we have a timestamp of none. It seems that our time here isn't actually corresponding to the logs. This is just the time it was ingested into Splunk. So honestly, not helpful for us at all. So the first thing that we need to do is fix our logs. We need to extract the data that we actually want out of them so it pulls up the right timestamp, user ID, username, so we can pull that information out of it. Now, I know a lot of what I'm going to do today is going to seem seem overwhelming if you're not used to working in Splunk and processing data. But the cool thing about TryHackMe is there's a lot of rooms that help with this. One room in particular I recommend is a challenge room that you can do after this one. It's called Fix It. It's a blue team challenge room where you're doing this very thing. You have data ingested into Splunk and you have to, well, fix the log so it processes properly in Splunk, and that's what we're going to do right now. So here in Splunk, if we scroll down to the bottom on the left side, there's this button here called Extract New Fields. Go ahead and click that. Now when we do this, it's going to give us a sample of all of our different fields, and let's click this first sample right here, this first field. And there's our sample field. We have it selected, and now we're going to click Next. Now it says we have two different ways of doing this. We can do a delimiter, but this is better for comma separated values or CSV values. That's where we can say, hey, everything separated by space or a comma, that's going to be a new field. Well, that doesn't work for us because our data is a little more complex than that. When we look at it up here, we have our timestamp right there, our event there, our user ID, our username, and our session ID. So we're going to use regular expressions. Now, if you've never used regular expressions, it's kind of like a almost programming language that you can use to process text and extract information from text. Splunk uses it so we can know what fields we want Splunk to identify. So we will click regular expression and we will click Next. Here we need to select the fields. Now Splunk makes this really easy as long as everything parses properly, which, spoiler alert, it's not going to, but if it does make it really easy. So for example, if we just highlight the timestamp here, we can create a field name. We'll say, hey, we want this to be the timestamp, and we'll add the extraction. So we have our timestamp identified. We have logout. Let's call this our event. So we'll highlight that, and we'll type in event, add extraction. We have this number right here, which is going to correspond to the user ID. So let's add that, user ID, add extraction. We have byte, and we know that corresponds to the username. We'll click add extraction. And then finally, we have a session ID. Now, if you're new to web apps, a session ID is a unique identifier for the user. Right now, if you're on TryHackMe, you have a session ID connected to your user account. When you logged into the application, you were assigned a session ID, and that's kind of like your authorization as you use the app, so each user is going to have a session ID. Even anonymous users receive a session ID often on a website to identify them to the web application. So we'll add that as an extraction. Now that we do that, we can look down and just look at the preview and see if it grabbed everything. So for example, we can see our timestamp right here. We can see our event. We can see our user ID. We can see our username, and we can see our session ID. But we already have an issue on the horizon, and we're going to come back to this, but I want to show you this process first. But for example, look at this log. It has an X marked next to it. Can you see why this wasn't extracted successfully? Well, all these other ones on the event, they only have one word: log out, watch camera, download recording, and watch camera. This one, the event is two words: login, space, successful. Our regular expression isn't correctly identifying that. We have the same thing right there. So we'll keep that in mind. We're going to come back and fix that later on. But first, let's just go through this process and see what it's like to extract fields automatically and have Splunk create the regular expressions for us. We'll click Next. Validate is just asking us to check it again. We know it's not going to get all of them. We'll click Next, and then finally, we will click Finish. Now we can click Explore the fields I just created in Search. And we can change our time once again to all time, so we get all the information, and hit Search up there. Now we have a little more information for us. We have this timestamp, which doesn't seem to be doing anything, but that's because it has the lowercase timestamp. Let's grab the uppercase timestamp right here, and I think it's actually showing it right there. So we have that one, but we could delete that one, I think. We'll say no on that, just so it's not confusing. And you may not have that. I think that's just me from playing around with it ahead of time. But we have the timestamp right there. That's the correct timestamp. We have our username. We have our session ID. We can probably hide source type as well. So I'm going to click that, and we'll hide that one to make it a little easier to read. Source, you know what? We can probably hide that one too to make it a little easier for us to read. Host, I say we can also hide. No, and you know what? Time we can also hide because we know time was, actually I don't think it'll let us hide that, but that's the time it was ingested. But we have our timestamp, our username, and our session ID. But you can already see we have some errors. So this looks beautiful. Timestamp, username, session ID, all of that stuff looks correct. We also, let's add event to this as well. Do I not have event on there? Let's add event. There we go. So we have our event information there. But you can see where it's kind of broken. We have this recording ID here in our session ID. So that's going to break our session ID. That's not going to be helpful. Same here. Our session ID should just be the KLA and everything following it, but it has a number 10 before it. And you can see we have that in quite a few places. So I think it did a good job on our username. And we can actually see that if we go over here and click username, we can see the different users represented. We have Byte, Software, Glitch, Marta, malware, freeware, and hardware. But on the other hand, if we look at our session IDs, well, those are broken. Some of them are correct, but most of them are broken because, once again, our regular expression that Splunk automatically generated for us isn't correctly grabbing everything as we need it to. So let's go ahead and fix that. We'll scroll up to the top, and we're going to click Settings. We'll click Fields. And now we will click Field Extractions. And we want to delete the one we just created. So on our filter, we can type CCTV. Click search, and we can see it right here. Let's go ahead and delete this one, and we'll click OK. All right, now that we deleted it, let's open up Field Extractor. And we need to select our source type. So source type is fine, we can keep that, but our source type, let's start typing CCTV, and we will see our CCTV logs right here. Our time range, we want to do that as all time, so click Presets. And then all time. All right, that looks good to me. I think. I don't know why it won't let me click next. Let's refresh. Control R to refresh. We'll see if we can get this working. So source type is correct. CCTV. Logs. Range. Presets. All time. Like so. And actually what I needed to do is I prefer to write the regular expression myself. It was asking me to select a sample one, but we don't want to do that. Remember, that's what kind of broke it the first time. We want to custom write the regular expression. So let's do that. I prefer to write the regular expression myself. Now over on the TryHackMe room, you may have noticed that it gives you a very long regular expression. We'll scroll down to it. So on the TryHackMe room, it just says this right, we're almost there, right here, and it doesn't explain it. So I know, looking at that, at least if you're me, this just looks like some crazy witchcraft, and you don't quite understand how or why that fixes it. So for those of you who are regular expression wizards, you can skip this part of the video. For the normal people like me, we're going to slow down, and I want to explain this regular expression we're using step by step. But first, let's go ahead and copy it and jump back over to our Splunk instance right here and type in our regular expression. I'll zoom in so you can see it a little bit better, and I'll walk you through this, at least some of the basics. The first thing I want to point out is the different fields. So we're going to change this to a capital T timestamp. The rest of it looks good. User ID is fine. Okay, that's good. So remember when we did it manually, we did that field extractor. And when we highlighted something like the timestamp, it asked us, what's the name of the field? Well, that's what we're doing here. So we have a timestamp field. We have an event field. We have a user ID field. We have a username field, and we have a session ID field. So that part should make sense. We also have this as an anchor tag. That means, hey, I want you to begin evaluating from the beginning of the text. So in other words, as you evaluate the regular expression, start right here in the beginning. Now, we first want to define our timestamp field. Now, even if you don't know regular expressions, this shouldn't make sense to you. If we scroll down and look at our timestamp, you can see we have a number or a digit, dash, digit, dash, digit, white space, digit, double dot, digit, double dot, digit. Well, look at this. Timestamp, we have digit, dash, digit, dash, digit, white space, digit time thingy. I can't think of what it's called. Digit time thingy. That's my very scientific word for that. And a digit. So that's how we're grabbing the timestamp. All of that's actually the same as our original regular expression. Nothing changes there. It was successfully grabbing the timestamp on every log that we had. Now, between our timestamp and our event, there is white space. So we have our white space right there. But here's where we fix our first issue. Remember, the reason our logs or our parsing failed initially is because it wasn't grabbing events that had 2 words in it. So it was not grabbing login successful. It was only processing things like login. So if we look at this, it would have processed logout correctly, watch camera, download recording, blah, blah, blah. But this is where it would have failed, because it was only accounting for 1 word as the event. Well, our regular expression fixes that for us. So it's saying, hey, check if it's login, and if it's login, do a space and grab any other words that's after login. So for example, if it's login successful, grab login and grab successful. Or if there is no login, if there's no other information there, or just grab whatever the single word is. So this fixes the event issue we had before. This regular expression will now correctly grab everything such as watch camera and login, but it will also grab login successful. So now that we have that, if we look over at our sample log right here, we have our event information down, and now we have a space, which we have right here, and now we want to grab our user ID. But we want to be careful with the user ID because we don't want to make it a required field. If we look back over at the TryHackMe room, we are given an example of some of these fields that broke it. So here's our sample log. You can see the first one that broke it was this one, which we have successfully fixed with our regular expression by grabbing login successful or just login. Whether it's a single word or 2 words put together, the event will now grab it. But note here, this login failed, it would grab that event, but there's no user ID. It just immediately goes to the username, and then we have this pass stuff, which is going to be confusing, but this one doesn't have a user ID. So we don't want to require a user ID, rather it is optional with a question mark there in our regular expression. So if it doesn't exist, well, that's okay. Just go ahead and skip it is what we're telling Splunk. So jump back over to Splunk, that is our user ID there. So we have our user ID, and now we want to add a white space and jump over to our username. In this example, it would be byte, but for our username regular expression here, we want to say username followed by, well, hey, it might be a blank space and some other letters. We don't know what it's going to be for sure, but if there's anything else after the username and before the session ID, we want you to capture that as well. And here's a reason we have to do that. If we jump back over to our TryHackMe room, look at this sample log right here. We have the username, and we have the username here. But in the first log, it goes username, and then it goes session ID. In our second log, it goes username, password, and then session ID. So if we only grab the session ID every single time after the username, well, it's going to break this one because the entire session ID is going to be pass, I'm the best, and then the session ID. So that's why we have that little stranger regular expression at the end of the username, and it's saying, hey, we want you to copy the username, do a white space, and then any other information you have leading up to session ID, also grab that as well, because we want to make sure we correctly capture the session ID, because that's going to be really important for our investigation, knowing what session IDs did what. Jumping back over to this, we have that, and finally we close with the session ID, which is just going to be a word or a phrase after that. We'll go ahead and click save. We have this, it's doing it, we'll click finish. And now we can explore the fields I just created in search. All right, now we have this. We don't need the index craziness. We'll just change it to this index right there, and we'll change this over to all time. So index that, all time logs, and now it should be a little more helpful for us. I'm gonna zoom out a little bit so we can see all the information, and we can hide some of these. So like recording ID, let's go ahead and hide that one. But now we have our timestamp, our username, our session ID, and our event. And just by looking at this, we can get a feel for what the logs are actually showing us. It's showing us what user was logged in, what their session ID was, and what they did. So we have the byte, or someone logged in as the byte rather, watching the camera, downloading their camera, logging in successful, logging in successful, logging in successful. But what makes Splunk powerful is its ability to parse through large amounts of data for our investigation. So this is just part one. We finally fixed the logs. We can actually begin our investigation now. So let's go ahead and begin our investigation after I get a drink of water, because I've been doing a lot of talking. The first part of our investigation is we want to figure out, hey, which users did the most activity on the CCTV system? And the way that we can do that is we're going to change our index over to our CCTV feed. And now We're going to do that bar icon. So if you saw me do that, if you use Linux, it's like the pipe icon. So we're going to grab that index, but we want to do stat. So we want to get stat information, count on events, and we want to know what user did the most events, and we'll click search. All right, and when we do this, we see statistics, which can be helpful. But the cool thing about Splunk is we can automatically generate charts for visualization. So click the visualization tab. We'll change it from bar chart over to pie chart, and we can see it here. So very quickly, we can see, all right, Byte had the most events, which we also know based on the TryHackMe background story is it seems like Byte may have been the one who deleted the footage. At least that is what the employees think. Now, Glitch, of course, believes Byte is being framed, but you can see why they came to that conclusion. Byte's account has been logged into, and Byte has performed the most actions. We also have freeware and Glitch and hardware and MARTA and malware, as well as software. Well, let's go ahead and get a summary by events, like which event was done the most. We saw a few events looking at the initial statistics. We saw things like login and login successful and download footage, things like that. So let's see which event was the most popular. We have our index CCTV feed. That all stays the same. We're going to do stats count, but by event. We'll hit search. And there we go. So this is helpful to us. We can see the largest event is people watching the camera. The other one is log out and login successful, which makes sense. We have a small amount of login failed ones, 16 in particular. And we have a small amount of, smaller of downloading recordings. At least those are the events that we see right here. We also have a small one of delete recording. So the ones that stand out the most to me is the login failed. The fact that we have 16, maybe that's normal behavior, but we want to investigate that further. Maybe someone's doing a password spray attack, trying to give access to other users' information. The other one that's interesting is download recording, but that's not necessarily suspicious. Maybe that was on purpose, but we have 2 instances of delete recording. Now remember, they said there was no footage of someone coming in to disconnect a server. Well, could it be there was no footage because the said footage was deleted? Possibly. Let's look at the failed login attempts first. We know we have 16 failed login attempts. Let's see if we can get a little more information about those failed login attempts. And the way we can do that is we'll do the index CC feed just like so, but we will do failed like that, and we can click search. All right. And now when we do this, when we already have our table set up here, we can see we have some login failed for Byte. We scroll through here. We have Glitch having login failed. So that's interesting. What stands out to me right away is we have a bunch of login failures on multiple users, but do you see what connects them all? Well, a few things. One, look at the timestamp. All of these login failures were back to back to back. So first it was the Glitch, then straight over to MARTA, right? And then straight over to Byte. The other thing that ties these together is note all of the login failures have the same session ID. So that's interesting. Now, a session ID I shared before is a unique identifier the web application can assign to a user, maybe during the login process. And during this login process, each login failure has the same exact session ID. What that tells me is one user was attempting to spray passwords against each one of these victim accounts, beginning with the Glitch, then MARTA, and then Byte, in order to figure out what is going on. Well, let's investigate the session ID itself. So we have our search up here, our index CCTV feed, CCTV feed. Let's go ahead and grab the session ID. I'm just going to highlight it, and I'm going to do Control C, and we'll go up here instead of failed. We'll replace our session ID up there, and we will click search. All right. And let's see what this session ID all did. So we can see the password spraying attack again right here. We have that session ID login into Glitch, login fail, login fail, login fail, login fail, login fail. Oh, login successful on Byte's account. And then the same session ID with the Byte user watching the camera, downloading a recording, watching the camera, deleting a recording, watch, download, watch, delete, watch, and then log out. So I think we can begin to piece together what is happening. An attacker did a password spray account against the different users. Now, a password spray attack is where we have some possible passwords and we just guess it against the user account. First, the attacker tried the glitch. Then the attacker tried Marta, and finally the attacker tried Byte and was able to log in successfully as the Byte user. Once the attacker logged in as Byte, they watched footage, they downloaded it, they deleted it, they watched it some more, they downloaded it, and they deleted it, and then finally they logged out. The deleting the footage may add up to the fact that the security company said there was no footage of anything happening. Well, there was no footage because whoever hacked Byte's account deleted the footage so it couldn't be seen. Well, if we remember back to when we were looking at the different sources, there's really two different source types that we could look at. We have the CCTV feed, but we also have the web logs we could dig into. Now, what might be helpful for us is to correlate these logs with the web logs. And the one kind of smoking gun that might connect the two together is the session ID. Of course, this session ID should be found in the web logs, and with that, we might be able to unravel the IP and other information about what is going on. So let's go ahead and give that a shot. We have our session ID already right there, but let's change our index over to web logs and click search. All right. And when we do that, we have a lot of fields that aren't exactly useful to us, so we can go ahead and remove those. Like we can remove the user field. We'll just do selected no like that. We can probably remove the cam ID field. We'll say no on that. The record ID, we'll say no. And let's see what fields might be helpful to us. One might be the client IP, so let's add the client IP. And what's the file one? File might also be helpful, so we can add file to it. Status, it looks like status is what contains the session ID, and we want to investigate the session ID, so let's grab that as well. So now, when we look at this, we see that from this session ID, we see what's going on. I mean, we have the delete recording.php, we have them looking at the different recordings, so we know that this session ID is definitely malicious. But we have a new piece of information. By correlating the two different logs together and by cross-referencing the session ID, we have a new piece of information, namely the client IP. This is the IP address of the malicious user who was deleting the footage. Maybe with this IP address, we can get even more information about the user. So let's check out this client IP. Now we can just click it and we can add it to our search. But let's delete the session ID because maybe there's other session IDs connected to this user, and click search. Now when we do this, we have some more interesting information. Right away, we see same IP address, but a different session ID. I wonder if we look up this session ID in our previous logs, namely in the CCTV feed, can we get any more information about the user? Is there another user? Does this session ID identify a different user? Because we know it's using the same IP. So if there's a user logged in as a glitch and maybe logged in as another account, but using the same IP by us cross-coordinating the logs, maybe, just maybe, we can identify our malicious user. So let's give that a shot. Let's go ahead and copy this new session ID that we found, and let's switch our index back over to CCTV feed, and let's instead look for this session ID we just discovered, and we'll click search. And ladies and gentlemen, I think we found the smoking gun right here. Malware, or Mayor Malware, thought he was going to be tricky. You see, what Mayor Malware did is he did a password spraying attack. He eventually compromised Byte's user account, and then as the Byte user, watched footage, deleted footage, and tried to cover up his tracks. But what he didn't realize is we knew his session ID. We then cross-coordinated or correlated or coordinated, I don't know what I'm trying to say, but we looked up that same session ID in the web logs. And the web logs revealed to us the source IP address. With the source IP address, we found a second session ID that was connected to the same IP. We then looked up that second session ID in the CCTV feed, and we noticed that ID is connected to Malware. So it was the Malware user who had the IP address that brute forced Byte's account, that performed the malicious actions, and we have identified our perpetrator. Malware did a password spraying attack, tried to blame Byte in order to also blame Glitch, I suppose, at the same time, and in order to cover his tracks, but we are threat hunters. We are investigators. We are in the SOC Miss SOC, and we cannot be thwarted, and we were able to unravel the mystery. Well, let's jump back over to the TryHackMe room and see what questions we need to answer. So we'll scroll down to our questions. Scroll. Eventually. So scrolling down, here's the summary. We already kind of saw that, and I already explained it. But let's see our questions. Number 1, extract all the events from the CCTV feed logs. How many logs were captured associated with the successful login? Well, let's jump back over to Splunk, and we can answer that with this right here. We'll just change the session ID here to successful, like so. Actually, we could probably just change it to success. Either one should work, and we'll click search. When we do that, we have 642 events. We'll jump back over to TryHackMe, and we'll say 642. Submit. What is the session ID associated with the attacker who deleted the recording? Well, if we jump back over to our Splunk instance right here, we can change success to delete and hit search. And we have this session ID right here. We'll copy that, Control C on our keyboard, and then jump back over to TryHackMe and type that in. Finally, what is the name of the attacker found in the logs who deleted the CCTV footage? Well, we know that. That is Malware. Mayor Malware, who tried to hide his tracks. We caught him. Now, if you want to learn more, I do recommend the Splunk data manipulation room. Another room I recommend is the Fix It room. I already mentioned that here on TryHackMe. It's a blue team challenge room where you're going to do some more work with Splunk and fixing logs. And finally, another room I recommend is the regular expression room on TryHackMe. If you want to get more hands-on with regular expressions, it's a great room that begins with basics, but slowly works its way up to more complex queries and more complex data processing with regular expressions. But congratulations, you have made it through day 17 of TryHackMe's Advent of Cyber. I know today was maybe a little more difficult, maybe something you were unfamiliar with, but the way you grow, the way you learn is you go through the more difficult things and you learn as you go. You Google, you troubleshoot, you figure it out, you watch videos like this, and hopefully you learn something in the process. So hey y'all, thank you so much for watching, for taking the time to hang out with me, and I will see you in the next one.